Hello, Bhaskar. Is my voice and screen clear? Yes or no? You can give me a thumbs up. Chalo, let's start. So, today's topic, our new chapter is quadratic equation. I told you that statistics was the last chapter for 11th standard. So now we'll be starting with the revision of the chapters that we didn't do, right? Out of them, the first one is the quadratic equations, correct? So let's go through this chapter together. I hope you know what is meant by a quadratic equation. We have all studied the quadratic equation, correct? So we'll dive deeper into the questions here, or you can say the chapter here in 11th standard by looking at the graphs. The main thing is graphs, and the other some small part, but most of the part we have covered. So today's lecture, you'll feel like this is a revision of your 10th standard, and from next lecture, we'll be starting the new things. Correct? So don't forget to pay attention as we are revising it. So let's start quadratic equation. First, we'll go to the definition. So here's the introduction. Now, a quadratic equation is basically a polynomial where the highest power is 2. A polynomial where the highest power is 2. As you can see here, this is the general equation of a polynomial. This is a general equation of a polynomial. So this general equation of the polynomial, as you can see here, when the degree is 2, that means only this much. Only this much. When the degree is 2, then that means that the equation is a quadratic equation. You can see the example here, correct? So this is meant by a quadratic equation. So let's get started. Expression. Now there is a very confusion to many of the students where they say that what is the difference between expression and equation. Now, as you have all studied like functions chapter we have already done. So what is the meaning of expression and equation? Expression is a number or variable or composition of variable and numbers. Basically, an expression doesn't have an equal to 0 sign, right? But for it to be an expression, it need to be equated to 0. When expression is equated to 0, then we get an equation. When expression is equated to 0, then we get an equation. Now, that means if, suppose, let's say this is my quadratic equation. So, what is equated to 0? This part is equated to 0. That means this part is my x. Please note, whenever an expression is equated to 0, I get an equation. So let's say this is an equation. Obviously, you can see this x square minus 4 equals to 0 is an equation. Now, what is equated to 0 here? X square minus 4 is equated to 0. That means x square minus 4 is an expression. I hope I am making sense. Bhaskar, are you there? Give me a thumbs up, Bhaskar, if it's clear. Hello, Bhaskar. Is it clear, Bhaskar? Give me a thumbs up. Okay, super. So let's see what we have next. 0 of a polynomial. Now, a polynomial, let's say f of alpha. Now we are all familiar with the functions. That's why I can easily say f of x is a polynomial. Then, zeros of a polynomial are the numbers which, when substituted in the expression, we get the value 0. Example, here you can see this is an expression. Now, if I substitute -1 in this expression, I'll get 0. That means -1 is a 0 of the expression. This is an expression. If I substitute 1 and 2 in this, I'll get 0. That means these are the zeros of the expression. Right? Now, an algebraic equation. What is meant equated to 0 is known as equation. Correct, guys? So let's see what we have next. Hello, Baz. Everyone left the meeting. No one's here. Ooh. Okay, we'll wait for some time. Okay, just recording then. Fine. So here's a differentiation between quadratic expression and quadratic expression is basically a polynomial of the form ax square plus bx plus c, where a, b, c are constant and a is not equals to 0. Obviously, guys, if a equals to 0, then the equation will not be quadratic, it will become linear. Correct? Now, quadratic equation means when this expression you can see here, ax square plus bx plus c, is equated to 0. That means we get ax square plus bx plus c equals to 0. Then this is called an quadratic equation. Now, as we all know, a quadratic equation has two roots. Now, they can be real or they can be coincident or they can be imaginary. But a two roots. Correct? Now, what is next? Why does a quadratic equation have two roots, guys? Because a quadratic equation is of degree 2. A cubic equation, on the other hand, is of degree 3. So it will have 3 roots. So degree of an equation means the number of roots it will have. Next, 0 of a quadratic expression. Now, since quadratic expression is of degree 2, how many zeros will it have? 2. Since degree 2, how many roots it will have? 2. So if you see, basically zeros and roots are the same thing. 0 is associated with expression. Roots are associated with equation. Zeros are associated with expression. Roots are associated with equation. Correct? So let's see what we have next. Yeah, solution of a quadratic equation. Now we have all done this. Solution of a quadratic equation means that getting the roots of the quadratic equation. That means if the quadratic equation is ax square plus bx plus c. Look at the screen here and look at the pointer. You will get to understand. If the quadratic equation is ax square plus bx plus c equals to 0, then the roots are x equal to minus 4ac upon 2a. I hope you know this formula. I hope you know this formula. Correct? So let's try it out here. Come on. Hello, Bhaskar. Are you there now? Is my voice audible? If yes, give me a thumbs up. Bhaskar, are you there? If my voice is audible, please give me a thumbs up. Bhaskar, is my voice audible? Please give me a thumbs up. Hello, Bhaskar. Bhaskar, are you there in the meeting? You just joined and bus. Khatam. Hello. Bhaskar, are you here? Huh. So what to do now? I'll solve just but you guys don't want to interact at all, right? Is your net okay? Bhaskar, is your net okay or not? Do you have good internet connection? Why, Bhaskar? Go to the tab room where you have Wi-Fi in the school. Which JNV are you from? Bhaskar, which JNV are you from? Medak. So is there no good Wi-Fi connection there? Is there no Wi-Fi connection in Medak? You are at home. Why? There is holidays for you all. Why holidays? Is there any festival going on? Pongal got over, beta. Till when you have holidays? 21. So till then you are at home. Okay, so now is the connection good? Should we start? Okay. Do you have pen and book? If not, please get up and get a pen and book. Got it? Book and pen. Okay, though it's very simple. Beta, please solve the quadratic equation by using the formula method. Let's solve it together. If you get an answer, you can write it in the chat box. You don't have to write the whole answer. You just have to say I got the answer or not. Then I'll solve. Is it doable, Bhaskar? Yes or no? Hello, Bhaskar. Okay. Please solve. I'll give you 2 minutes. Chalo. I am also solving simultaneously. Please check your solution here. So I got one of them as minus 10 minus 2 by 2 root 3 and minus 10 plus 2 by 2 root 3. So just a second, I'll bring some water. Yeah. So what are the answers that we got? We got minus 12 by 2 root 3 and minus 8 by 2 root 3. Did you get the same answer, Bhaskar? Did you get the same answer? So it is minus 6 by root 3, comma, minus 4 by root 3. So, Bhaskar, did you get the same answer? Hello, is my voice? Are you there? You left. Hello, yeah, come on. No one's in the class. Whew. Okay, fine. Continuing. What we have next is nature of roots. Now, I hope you understand the meaning of nature of roots. There are three natures that we can think of. The first is both of the roots are real and distinct. Distinct means both are different, both are not alike. Second is both of the roots are real, but both of them are same. And the third one, that means both of the roots are complex, or you can say imaginary, or you can say not real. Correct? So for this, we have a condition which is called discriminant. What is discriminant? You can see on the screen. Discriminant is b square minus 4ac. Discriminant is b square minus 4ac. Now, this discriminant can be greater than 0, equals to 0, or less than 0. If the discriminant is greater than 0, then roots are real and distinct. If equals to 0, then roots are real and equal. And less than 0, then roots are not real, or you can say now imaginary. Correct? So what we have next, let's see, we have some questions on that. So here, it's an equation given, and we have to show that its roots are always real. What is meant by its roots are always real? That means its discriminant should be, that is 2, prove that its discriminant should be greater than or equals to 0. Now, first, let us simplify the quadratic equation in the general form. So, we can write it as x square minus a plus bx plus ab minus h square equals to 0. So what is discriminant, guys? If we compare it, then I'll get ax square plus bx plus c equals to 0. So discriminant will be, or you can say delta also. Delta will be equals to b square minus 4ac. What is b square? B square is a plus b, the whole square minus 4ac, ab minus h square equals to 0. Sorry, not equals to 0. You have to prove this. You have to find its value. Okay. So here we get a square plus 2ab plus b square minus 4ab plus 4h square. We can cancel out ab terms. I'll get a square minus 2ab plus b square plus 4h square. What is a square minus 2ab plus b square? It's a minus b the whole square plus 4h square. Now, as you can see, these terms, both of these terms are square terms. And what do we know about square terms? That it cannot be less than 0. It can be equal to 0 and it always be greater than 0. So we can conclude that, just a second, sorry, we can conclude that discriminant is greater than or equals to 0, which means the roots are real. Correct? I don't care if they are equal. I am only interested in whether the roots are real or not. Let's move on to the next. Here, Here in this equation, we have been given this quadratic equation as equal roots. What does that mean, guys? That means its discriminant will be equals to 0. Its discriminant will be equals to 0. Let's compare it. Ax squared plus bx plus c, right? But it is not in the standard form. So let's write in the standard form. It will be x squared minus 50 minus 2mx plus 8m equals to 0. That means if we write in the standard form x squared minus 2mx plus 8m minus 15 equals to 0. Let us compare it. So I get ax squared plus bx plus c equals to 0. So what is discriminant? Discriminant is b squared minus 4ac equals to 0. What is b squared? 4m squared minus 4ac 8m minus 50 equals to 0. 4 and 4 will get cancelled. I'll get m squared minus 8m plus 15 equals to 0. What are the roots? Okay, Bhaskar, you are back. So, yeah, Bhaskar, tell me, what are the roots of this quadratic that we got? Bhaskar, are you able to hear me now? What are the roots of the quadratic that we got? M square minus 15 plus 8. Come on, it's not that difficult. What are the roots of this? I want your answer in the chat box. Come on. Come on, Bhaskar. What are the roots? Do you know to factorize, Bhaskar? Hello, Bhaskar. Are you able to hear me? Bhaskar, are you able to hear me? Hello. Hello, Bhaskar, are you there? Hello, Bhaskar. Please sit somewhere where you have good internet connection. Do you have Wi-Fi at your home? Hello, Bhaskar, are you there? Yeah. Okay, fine. No one's there again. He left. So here we can factorize it. M minus 3 into m minus 5 equals to 0. So we got the two values of m equals to 3 and 5. M equals to 3 comma 5. M equals to 3 comma 5 are the roots of this equation. Let's see what we have next. Relation between roots. Now this is the most important part of quadratic equation. Excuse me, where many questions are asked in JEE mains from this. What does this mean, guys? This means that whenever a quadratic equation is given to us, we can always and always get two relations from there. That means we can get the sum of the roots and the product of the roots. We can always and always get two relations, sum of the roots and one of the roots by formula method is alpha equals to minus b square plus under root of b square minus 4ac upon 2a, and beta equals to minus b minus under root of b square minus 4ac upon 2a. Correct? Now, if I do alpha plus beta, then the square root part will get cancelled and I'll get minus b by a. Similarly, when I do product, I'll see a square minus b square in the numerator, a minus b, a plus b. Again, b square and b square will get cancelled and I'll get c by a. So always remember that sum of the roots is minus b by a, or if you want to remember it general way, then sum of the roots is coefficient of x minus coefficient of x upon leading coefficient. I hope you know, but the a, which is the coefficient of x square, a is the coefficient of x square, is called leading coefficient. Coefficient of x square. It's called leading coefficient. I hope I'm clear. So sum of the roots is minus coefficient of x upon leading coefficient. Product of the roots is constant term upon leading coefficient. I hope it is clear. Let's see what we have next. Now, once we know the relation between roots, that is the sum of the roots and product of the roots, we can easily, guys, easily get the quadratic equation. How? See here, if you can see, ax square plus bx plus is a quadratic equation. I took a common, and if you check it, this is nothing but this part. Sum of the roots is minus times sum of the roots, because sum of the roots is b by a. This is product of the roots, which is c by a. So in general, I can write the quadratic equation as x square minus sum of the roots into x plus product of the roots equals to 0. X square minus sum of the roots into x plus product of the roots equals to 0. I hope it is clear. Let's see what we have next. We have the questions. Now, here comes the part of your algebraic identities. I hope you all know it. Please let me be very clear. If you don't know your algebraic identities, you will not be able to solve the questions. So I hope every one of you all knows the algebraic identities. What am I talking about? Here it is. We know that a cube plus b cube is equals to what? It's equals to a plus b, the whole cube, minus 3ab into a plus b, right? So here, by using this, I can find or solve this question. What does the question say, guys? The question says alpha and beta are roots of its equation. Then I told you whenever a quadratic equation is given, I already have two relations. Product of the roots is C by A. Now we have to find alpha cube plus beta cube. So alpha cube plus beta cube is very simply can be written as alpha plus beta, the whole cube, minus 3 alpha beta into alpha plus beta by using this identity. Now we know the values of alpha plus beta. So minus b by a, the whole cube, minus 3 into c by a into minus b by a. So what do we have here? Minus b cube by a cube plus 3bc by a square. If we try to take LCM, we'll get 3abc minus b cube upon a cube. This is my answer. I hope it is clear. Right, guys? Sure, let's move on to the next. Here. This is a very interesting question, guys. The same as the previous one. But we need to know algebraic identities. We need to know algebraic identities. Now let's first simplify it. Here we can take alpha raised to 4 and beta raised to 4 common. What I'll be left with? I'll be left with alpha cube plus beta cube. Just now we have studied to write the value of alpha cube plus beta cube. It is alpha plus beta, the whole cube, minus 3 alpha beta into alpha plus beta. Now what is product of the roots? It's c by a. What is sum of the roots? It's minus b by a. We can directly use this value here. I'm directly using this value, guys. 3abc minus b cube upon a cube. So I can directly write it here. What? 3abc minus b cube upon a raised to the power 4. Sorry, a raised to the power 3. So now we'll get c squared into 3abc minus b cube upon a raised to the power 5. A raised to the power 5. Correct? This is our answer. Are you clear? Let's move to the next. Find the quadratic equation whose roots are. Just now we have studied. What have we studied, guys? Find the quadratic equation whose roots are. How to write a quadratic equation? I can write the quadratic equation as x square minus sum of the roots into x plus product of the roots equals to 0. That means x squared minus sum of the roots plus product of the roots equals to 0. That means x squared minus x minus 6 equals to 0 is my answer. I hope it is clear. Very simple, guys. Let's see what we have next. Chalo, this is a nice question. If alpha and beta are the roots of the equation, find the quadratic equation whose roots are. I think question is repeated. We'll cancel out this. Yeah. It's the same thing. So yeah. So it's one extra step than what we had done in the starting के दो questions. Correct? One extra step, guys. Just one. Now, these are the roots. Let us find their sum. Because to find the quadratic equation, we need sum of the roots and product of the roots. The sum of the roots alpha square plus beta square plus 1 upon alpha square plus 1 upon beta square. What I can write alpha square plus beta square. Let us simplify first. Alpha square plus beta square plus alpha square plus beta square upon alpha beta the whole square. Now, if you know the algebraic identities, alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. What is sum of the roots? Minus b by a minus 2 into c by a. So let us substitute these values here. What I'll get? I'll get b square minus 2ac by a square plus b square minus 2ac by a square upon alpha beta the whole square, which is c square upon a square. This will get cancelled. Okay, so I'll get b square minus 2ac upon a square plus b square minus 2ac upon c square. This is the sum of the roots. If you want, you can take LCM. If you want, you can take LCM. But then too, it doesn't make it more easier. Let us try to find product of the roots. What is the product of the roots? Product of the roots will be alpha square plus beta square into alpha square plus beta square upon alpha beta the whole square. Alpha square plus beta square the whole square upon alpha beta the whole square. What is alpha square plus beta square? Here it is. B square minus 2ac upon a square. B square minus 2ac upon a square. Let me write it here. B square minus 2ac the whole square upon a raised to the power 4. What is alpha beta the whole square? Is c square by a square. So this a square will get cancelled. What I'll get? I get b minus 2ac upon ac the whole square. This is the product of the roots. So what is my quadratic equation? Quadratic equation is x square minus sum of the roots. This b square minus 2ac upon a square plus b square minus 2ac upon c square into x plus product of the roots. What is product of the roots? B, oh, okay, it was b square. B square minus 2ac upon ac the whole square is equals to 0. This is my final answer. Let's see the next. Common roots. This is the last concept for today because by then we will be reaching our time limit. So yeah, guys, common roots. Now, if I have been given two quadratic equations, how many guys? Two equations. And both of them will have their own roots. That means each of them will have their two roots. Correct? Out of those two roots for each of them, one of the root can be common. One of the root can be common. So let us say that the quadratic equations given are this. Look at the screen. And we said that alpha is a common root. So if alpha is a common root, alpha must satisfy both of these equations. That means we'll get these equations. Once we get these equations, what can we do, guys? We can solve them simultaneously for alpha. And after solving them by cross multiplication method. I hope you remember this method from your school days. So using cross multiplication, we get this. And after using the condition, we get the value of alpha square and alpha. We substitute this value here. If we substitute this value here, we get a very beautiful, not so beautiful condition. Now, this is a condition for one of the roots. This is a condition for one of the roots to be common. And unfortunately, you have to remember this condition. You have to remember this condition. Excuse me. So, yeah. Guys, if both of the roots are common, then you have to laugh because both the given quadratic equations are same. Let's say I have a quadratic equation x square minus x minus 6 equals to 0, and one of them is 3x square minus 3x minus 18 equals to 0. Both of them will have the same roots. Why? Because both of the equations are same. Both of the equations are same. So if both of the equations are same, then both root will be common. So what is the condition for one common root? This. What is the condition for both roots common? That their coefficients must be proportional. Coefficients must be proportional. So please guys remember these conditions for the next class because we'll be doing questions on them. Our time is over. So yeah guys, thank you very much for joining. I hope you understood it completely. And thank you guys. Bye-bye everyone. Take care. Tata everyone. Take care. No one is there.